Modernage MCQs Physics second year, unit number 19, Atomic Physics, part 3. What is the energy of electron in first excited state of hydrogen atom? Option A, minus 13.6 electron volt. Option B, minus 3.4 electron volts. Option C, minus 1.5 electron volts. Option D, minus 0.5 electron volts. The key is minus 3.4 electron volts. Therefore, the correct option is B. Reason for positive state n is equal to 2 and the equation for the energy En is equal to minus E naught divided by n square becomes E2 is equal to minus 13.6 electron volt, which is the value of E naught. It is the ground state energy divided by 2 square, which is equal to 13.6 electron volt divided by 4, which is equal to minus 3.4 electron volt. Hence, the energy of electron in first excited state is minus 3.4 electron volts. The radius of first orbit of hydrogen atom is 0.053 nanometer. A student calculated the radius of third orbit. Option A, 0.477 picometer. Option B, 0.477 nanometers. Option C, 0.477 micrometers. Option D, 0.477 millimeters. The key is 0.477 nanometers. Therefore, the correct option is B. Reason from the relation or n is equal to n square or 1 is equal to n into Bohr radius. Bohr radius is denoted by r naught. Therefore, Rn is equal to n square r naught, where r naught is 0.053 nanometer. We have the radius of the third orbit R3 is equal to 3 square into 0.053 nanometer, which is equal to 9 into 0.053 nanometer. Simplification gives 0.477 nanometers. Hence, student calculated the radius of third orbit 0.477 nanometers. The radius of an orbit of hydrogen is 16 times the radius of first orbit. What will be the quantum number of the orbit? Option A, 25. Option B, 16. Option C, 9. Option D, 4. The key is 4. Therefore, the correct option is D. Reason. The radius of the nth orbit is Rn is equal to n square R1. Given is Rn is equal to 16 R1 and which is equal to 4 square R1. Therefore, n square is equal to 4 square. Rn is equal to 4. Hence, the quantum number of the orbit is 4. An electron revolves in second orbit of hydrogen atom for 10 power minus 8 seconds with energy. Option A, minus 13.6 electron volt. Option B, minus 3.4 electron volts. Option C, minus 1.5 electron volts. Option D, minus 0.5 electron volts. The key is minus 3.4 electron volts. Therefore, the correct option is B. Reason, the energy of an electron in nth orbit is En is equal to minus E naught divided by n square. Therefore, the energy in second orbit is E2 is equal to minus 13.6 electron volt, which is the energy of the ground state, divided by 2 square, where 2 is the quantum number of the second orbit, which is equal to minus 13.6 electron volt divided by 4. Simplification gives minus 3.4 electron volts. Hence, an electron revolves in the second orbit with energy minus 3.4 electron volts. An electron revolves in the fourth orbit with energy. Option A minus 13.6 electron volts, option B minus 3.4 electron volts, option C 1.5 electron volts, option D minus 0.85 electron volts. The key is minus 0.85 electron volts. Therefore, the correct option is D. Reason: the energy of an electron in nth orbit is En is equal to minus E naught divided by n square. Therefore, the energy in fourth orbit is E4 is equal to minus 13.6 electron volt divided by 4 square, which is equal to 13.6 electron volt divided by 16, which simplification gives E4 is equal to minus 0.85 electron volts. Hence, the energy of electron in the fourth orbit is minus 0.85 electron volts. If the wavelength of first and second transitions are lambda 1 and lambda 2 in Lyman spectral series, then option A, lambda 1 to lambda 2 is equal to 14 to 9. Option B, lambda 1 to lambda 2 is equal to 14 to 5. Option C, lambda 1 to lambda 2 is equal to 11 to 5. Option D, lambda 1 to lambda 2 is equal to 11 to 9. The key is lambda 1 divided by lambda 2 equal to 11 to 9. Therefore, the correct option is D. Reason: formula for spectral transitions is 1 divided by lambda is equal to r into 1 by p square minus 1 by n square. For the first transition, 1 over lambda 1 is equal to r into 1 divided by 1 square minus 1 divided by 2 square, which is equal to r into 1 divided by 1 minus 1 divided by 4. Simplification gives that 1 divided by lambda 1 is equal to 3r divided by 4. R lambda 1 is equal to 4 divided by 3r. For the second transition, 1 by lambda 2 is equal to r into 1 divided by 1 square minus 1 divided by 3 square is equal to 8 r divided by 9. Simplification gives that lambda 2 is equal to 9 divided by 8 into r. Therefore, the ratio is lambda 1 to lambda 2 equal to 4 divided by 3r divided by 9 divided by 8r, which is equal to 32 divided by 27. Simplification gives that lambda 1 to lambda 2 is equal to 11 to 9. Hence, the ratio is 11 to 9. The wavelength is reciprocal of Rydberg's constant for option A, Boston series, option B, Brackett series, option C, Lyman series, option D, Balmer series. The key is Lyman series. Therefore, the correct option is C. Reason: formula 1 divided by lambda n is equal to r into 1 divided by p square minus 1 divided by n square. The factor 1 divided by p square minus 1 divided by n square is unity if p is equal to 1 and n tends to infinity. It is the condition for Lyman series. Therefore, 1 divided by lambda n is equal to r. Lambda n is equal to 1 by r, which is the reciprocal, and it is for the last transition in Lyman series. Hence, the wavelength is reciprocal of Rydberg constant for Lyman series. Helium neon laser device is filled with option A 100% of helium, option B 85% of helium, option C 65% of helium, option D 45% of helium. The key is 85% of helium. Therefore, the correct option is B. Reason: in helium neon laser device, Neon is lasing gas and helium gas is present to shift the neon atoms to metastable state by collision. For maximum chance of collision of excited helium atoms with neon atoms, the device is filled with 85% of helium. Hence, a helium neon laser device is filled with 85% of helium.